So I'm going to log into Vocarium through the student view. And the lab that I wanted to cover is this analyze data with Redshift lab here. So what we're going to do is click on this link here, my work. And then from here, let me just do a quick overview of what's covered. So in this lab, actually, we're going to get into something that a lot of big data people would potentially need to interact with a columnar database. And you can see that it actually handles multi-petabytes of data. Also, it can handle really, really large data sets and talk to S3 as well. And if you're going to get a job as, let's say, a data engineer or a cloud architect, probably you will need to master this. The good news is I think just this demo will be a good start to get you to master this. So in this particular lab, we're going to spin up a Redshift cluster. We're also going to create the Redshift cluster, load data from S3, and then also learn how to query it with SQL. So really there's nothing necessarily required to launch this other than a Vocarium account. So I'm going to click on this Start Lab button here. And it takes, let's say, 2 minutes or so. And then once this spins up, we'll be able to access AWS. So just give this a second or so. All right, so let's see here. So it's starting the lab. Yeah, so one thing to cover here now that the lab is launched, and I'll maybe put it over in this window, is that for big data itself, there really isn't a great solution for having the cost low because of just the description, right? Big data means that you're dealing with petabytes of data, and so the resources are often very, very expensive. So I think the solution here is to actually make sure that you're actually using lab-based technology. So you're, basically the fact that you have access to Vocarium is a pretty huge, capability that many people don't have access to. So I think that's really the best possible solution for people. And let me also make sure that I give everyone access to this course and the link here. Maybe someone could share a link to the course here as well. So let's see, invite, copy URL. Let's do this. Okay. Great. So the inside of this lab here, what I'm going to do is I'm gonna go through here and let's make sure I can access this. Make sure. Okay, there we go. So here's our scenario: is that in this lab, you're a data analyst who works for an enterprise that manages ticket sales for a music company. The company has a web app that needs to aggregate the sales between the buyers and the sellers. And so in this particular scenario, the manager, there's a very realistic scenario, says, hey, we have all this huge, big data. We know you're a cloud certified architect that has a degree from, a top university. we need you to generate these reports. So here's what the architecture would look like. Is first you need to make sure that you have the IAM role set up. You need to have access to S3, and then also you need to make sure that you have a Redshift instance. So the first thing typically when you're spinning anything up and controlling it is this whole IAM system to make sure that the resources you have access to can connect to other resources. So I'm going to first go to IAM here. You can see here's a link to IAM. And one of the things that we'll do is click on this roles icon here, and you can see that I can search for this lab role they said is my Redshift role. So if we look at it and we scroll through here, you'll be able to see that it has this particular role has Amazon S3 read only. So what's important about this is that I'm going to be able to get access to S3 from Redshift. So the next thing that we'll need to do is go through here and create a cluster. So what does the cluster look like? You can see that, and this does go to an earlier question about, why is it so expensive to spin up a big data system? Is that the nature of big data is that you have things like a leader node, which is the master, and then you have these compute nodes that are delegating the requests. They're just a very large system that's very expensive, and the best way to deal with this is to have a lab-based environment. So what we're going to do next here is we're going to go to the Redshift console, and we're going to spin one up. So I'm going to go to Redshift here, and what I will do is I'm going to actually use, there's a newer button here. Let me just make this over. There's a new UI here that I can use, and I can say create cluster. And then you'll notice that you can actually select different kinds of machines, and this could be very, very expensive. Like if you pick that, look, $13 an hour, that is not something you want to spin up on your own personal account. Fortunately for the lab, we actually get this for free, and here's a DC2 large. And also we can see that there's going to be two nodes. So if we look at the diagram, it's going to be, here's the leader node, and then here's these two compute nodes that are going to make a data warehouse. So next up, you can see actually the estimated cost. So again, I wouldn't want to spend $360 a month for this. We're very fortunate we have a lab that allows us to do that. The other key details to be aware of are the name of the cluster. So this is fine, we'll just leave it Redshift cluster. And then this is a database port. And this is important to remember later, because the two things that really trip people up with AWS are going to be the IAM roles, which is making sure that the resources can talk to each other, and then also the ports, so the network ports. Can I actually talk to TCP 5439? This is just something to remember. So next up, I'm going to put in a password here, and they want us in this lab to put in this really simple password, and I can even show the password to see it. And then I believe that's all I need to do to create the cluster. And this will take a few minutes here to create this cluster. So while this cluster is being spun up, the next thing that I'm going to do is I'm going to create a security group. So why are we going to create a security group? Well, that's where we're going to open up the port so that I can communicate with it. So I'm going to go over to EC2. That's where you create the security groups. And then from here, we can scroll down to security groups, and we will go here and create a new one. So typically, one thing to be aware of here when you're setting up new services is that Amazon gives you a default security group, but you don't really want to set up a production environment where you are changing the default security group, because it affects every single service that you have. More likely, you want to use the principle of least privilege, which is you create a specific security group for the thing you're trying to do. So you would create a security group for Redshift, or you create a security group for Elastic MapReduce, or you create a security group for maybe a web application. So you want to tie these security groups to the thing you're building. So that's what we're going to do. We're going to say create security group, and then we'll just copy and paste what they want us to put in here. So Redshift security group, and then we'll say security group for my Redshift cluster. And then what we'll do is we'll add a rule. And if you remember earlier, we had the port 5439 here. That's going to be the port that the Redshift cluster is listening on, and the protocol is going to be TCP. And then here, this is where we would tell it that we want anybody to be able to access that, anyone to be able to access that information. And then finally, I can actually add a description to it. I mean, this is optional. You don't necessarily have to put this in there. And I don't even know if I can, maybe I can get at this from my window. Yeah, here we go. Redshift. So now that I've got that, the next thing that I'm going to do is I'm going to go back to my cluster, and I'm going to configure it to make sure that it has access to the security group. So if I go to this tab here and I select it, I can go to this section, and I should be able to say actions. First I need to select it, so I might need to make this a little bit bigger. Let's see here. Clusters. Let's select this, and then we'll select actions. I think it needs to first finish modification, so this will take just a second, and then once it's finished configuring itself, then I'll select this action. So just give us a second here. A couple things to point out while it's spinning up is you can see metrics here as well about the performance of this, and I believe you can also go to the dashboard, and it will give you an overview of things like CPU, alarms, kind of an overview of all the different things. So if you were a big data architect and this was the system that your company used to get analytics data, this probably would be one of the things you'd look at all the time is this dashboard that shows you a high level, like, how many clusters do you have, how many nodes are in your cluster, what's the status of the cluster. In this case, we can see it's being modified, so something's being done to it. And then also you could look here, like number of queries, database connections. These are all things that in a real world scenario, when I've dealt with large scale databases, these are really important. So for example, database connections is a classic problem. If you overwhelm your database with too many connections, then it could cause very poor performance. So instead of maybe having all the machines directly talk to the database, you could have maybe a web service proxy all the requests, and it only has one dedicated connection to the database. So instead of directly giving everybody access to a database where they open up a bunch of network connections, you could proxy it, or you could set up maybe Amazon SQS in front of it, like we covered earlier, and you could put work in there and then have that work get delegated to the database. So these things can be really important, especially in a kind of a crisis situation to look at. Another thing as well I can cover while it's getting set up is this CloudWatch dashboard. Is you can set alarms for things as well. So one of the things you could do potentially is create an alarm on the CPU of maybe Redshift. So I could go through here and look for Redshift and look at node metrics or some other information. So here we go, node metrics. You can see like network bandwidth, the IOPS, so like how many requests per second to the disk are happening. What's the size of is the disk space being about to be too full, and the database is going to fail because of it. A bunch of these could be alarms, right? You could add one of these, and then you could then do alerts based on those alarms. So that's in a real world production environment. It's a critical thing to have graphs and alarms set up so that you know what's happening. Okay, so this thing looks like it's available now. So again, I'll go to my cluster and I'll select it and go to actions, and then I'll say modify. One of the things that I'll show here that's kind of an interesting thing to be aware of is that this is another thing to be aware of in a crisis situation, is that you can also select resize. And I've done this before. So you can on the fly, for example, just make something way, way bigger if you really have a problem. And you can see that it'll only make the system unavailable for a few minutes. So if you had a really big problem you had to solve and it was a crisis and people needed a solution really quickly, you can actually, in most cases with the Amazon resources, you can resize it dynamically if it doesn't have auto scale capabilities. So again, I'll go back here. I'll go to modify. And then the big takeaway is that under the security group, you can see it has access to default, but I also need to tell it to get this Redshift security group so I can talk to it. And I believe that's the only thing I need to do here. So let's go ahead and modify the cluster. And this should take just a second to modify because it's a very small change, but you can see here that it says it's being modified. So the next thing that I'll do is I'm going to load the data into Redshift. So this is really where something like Redshift shines, and especially with AWS, is in a big data situation, you're going to have to figure out a way to put a ton of data quickly and easily into your database. So what are some of the things that Amazon Redshift can store? You can see it's going to be text data, this Apache Avro format, JSON data, Parquet, this ORC format. And so what we can do is we can first create the schema in the Redshift database, and then we can take that data and then, or take our data from S3 and then upload it. So first thing we're going to do is we're going to go here to the editors. So I'm going to click on this query editor here, and I'm going to connect. Although it may take us. There we go. So it's allowed us to connect. So what I'm going to do is I'm going to first create this schema here. So go to the schema drop down. Let's go ahead and do this. So let's create this users table here. Let's just double check. Yeah, just create the users table. And we can just paste this in. So I think that's actually already in there, but I'll just paste it in again just to be sure. So here's our users table. This would be, pretty typical to a database. Here's all the users' data, where they're from, what things they like. So I'm going to go ahead and run that. And then that's going to take a second and create that schema. And you can see what happens is below here, it'll give you basically a status. And here we go. We can see that it was able to successfully create that. So next up, I'm going to create another table, which is like a date table. So I'll go ahead and copy this, and then I'll make another query button here. So I'll say just query 2, and then I'll just paste this in here. And then this is going to create the second table. It should take just a second. All right, and then let's create a sales table here. This will be the third table we create. Here we go. And this should be a second. Okay, that was easy. Now that we've got the schema created, we have those 3 tables, we can start pumping over the data from S3, which is, again, the data lake that can hold infinite amounts of data. So what we're going to do is we're going to copy this command here, then I'll explain what it's going to do. So in this particular command, what it's going to do is there's a bucket in S3 which has the ticket data, and we're going to copy it. We're going to copy it into Redshift. We're going to put it to the users table, right? So this is basically all the raw users data, and this would be a perfect example of how in the real world you would take some data that was in S3 and just dump it into a Redshift system. So one gotcha though is if you notice here that I'm going to have to go back to my IAM role and make sure that I can actually fix it. So the next thing that I'm going to do is go to here, and I'm going to go back to my IAM role. And I'm going to find that role that I had before, which was the, I think it was called something Redshift. Yeah, my Redshift. And see this R in here? This is the privileges. I have to basically copy that, go back to this, and then swap it out. So, but I have to swap it out right here. So this is probably one of the trickier things to be aware of is that you have to give this SQL command the right credentials so that it can copy the data from S3 into this users table. But once we do this, we can just say run, and it should take maybe like 30 seconds or so, and then it will be able to do that. Oh, we have a problem here, and we can see that this one says invalid user is not authorized to assume the role, and this could be because I know what the problem is that I forgot to do one step, which is I forgot to associate the IAM role with this database, which is really easy to do. So it's actually, I'm glad we made this mistake. So I'm going to go back here, and I'm going to go to the cluster again, and I'm going to select modify, and then let's see here, actions, modify, and I'm going to go to network and security, and I'm going to go to database configuration. Let's see here, there's a section here that I'm missing that has, maybe it's under configuration, that basically has the security credentials here somewhere. So where is that? That's under, it is under, it might be because the window is small, I'm missing it here, but let me look here. So it's under clusters maybe. Let's go here. Let's go, oh, manage IAM roles. There we go. So basically this thing doesn't know about S3 at all. So that's why I can't talk to it. So I'm going to go here and go to my redshift role, and then I have to select this button, add IAM role. And now when I do this, we can go back to my the editor here, and then from the editor, I can rerun this copy command, and it should, in theory, work. So let's see if this works. So pretty simple way to make a mistake. So we still have a problem here, which is that not authorized to assume my Redshift role. So what I'm doing something wrong here, which maybe it didn't. Maybe it took between the time I ran it. Maybe the change didn't happen yet. Let's see. There we go. So yet one more problem, which is pretty common, which is there's all kinds of ways you can trip yourself up. Is I did the SQL query while the IAM role change was happening, and it didn't reflect yet. So now it's all good. The modification to Redshift occurred, and I copied it, and we're able to get that data into the users table. So next up, I'm going to now copy the date data. So I'll again go here, and I will go to the make one more SQL connection here. So I need to go, I got too many of these things open. I'm gonna have to close some. Let's see here. Here we go. and the other thing to be aware of is there's a little icon here where I can look at previous queries. And so I need to copy the credentials for this next query that I'm doing. So I'm gonna go ahead and do that. So I'm gonna go to, let's see, is it query 9 or which query is it that I'm on here? Oh yeah, here we go. So this is going to be the date data. Okay, so I'm going to copy this line, which I got from the other one. There you go. Credentials, that looks good. And I believe you can even format the query, format selected. So I can even clean it up if I want and go like that. And it just makes it a little bit cleaner. Okay, so run that. That looks like it's good. This, I think, again, should be pretty quick. Okay, and then there's one more bit of data, which is the sales data now. So again, I'll copy this. I will go back up here. Maybe I'll get rid of a couple of these queries and make another one. And again, I can go to one of these previous ones like this, grab this credentials string and go to, we want to copy, which one do we want to copy? We were at, was it 3? Yeah, sales, okay, sales data. So yeah, and then I just need to swap this out. There you go. Okay, run this. And then once this is copied in, the only thing left to do is to go through here and query the data that we populated into Redshift. All right, pretty quick. Okay, now we can query the data. So now the data is loaded, we can see the overall structure of the sales table. So what we can do is we can go to the sales table itself, and there's a preview icon. So if I go up here and I just refresh this and I look at sales, let's change the schema to, I think, public. And then you can see here that we've got sales, user, and data. Those are the 3 things we populated. Let's just look at the sales data. And then I believe, yeah, well, you can just look at the preview, right, and see exactly, you know, what's inside of this by either showing the schema or doing the preview icon. So yeah, here we go. Here's our preview of the sales data. So this would be all things that you would do if you were in charge of the big data infrastructure at your company. Next step here, we're going to do a SQL query, and we're going to basically, you know, figure out some sales data. So again, this would be really common. You know, someone's like, hey, we need you to figure out what's going on with our customer sales. Why don't we figure out, you know, essentially the quantity sold. And right here, we can look at, I believe, on that date, this is going to calculate all the sales, and you can see that it come up with 210. So they sold 210 things on that particular date. Next up, let's find the top 10 buyers. So again, I can go through here and put another SQL query in here. This will be top 10 buyers. And really, one of the big takeaways with something like Redshift is that it can handle such a gigantic data warehouse system. So you could be putting, you know, petabytes of data in here and get really pretty reasonable query performance here. Here we go. Here's our last 10, the top 10 buyers. So, you know, a couple things to point out here would be that you can go back again to this dashboard and see, look, here we go, number of queries, database connection, disk space use, CPU utilization, right? This would be where I could decide whether maybe I am having some performance problems here and I need to make more nodes in my cluster to get a better performance. Or maybe I notice that the number of queries, like a lot of maybe the data science team is really hammering the database, and again, we need to expand the cluster to make more of them because it's having an adverse performance here. But that's kind of Redshift in a nutshell. And if you wanted to then go through here on your own and go through some of these challenge questions and write some SQL, it would be a great way to get experience. So in a nutshell, I think the big takeaway here is that it really is a lot of work and very expensive to do big data operations on your own in your own account. And so for the people that have access to something like Vocarium, really you're have a huge competitive advantage because you can try out something. It's like, how would you learn to be a race car driver with $1 million race cars? Well, someone's got to let you try out the race car, and that's basically what this Vocarium lab is. So I'll go ahead and stop that.